Here's a tutorial on how to create a seismic spectrum based on the data you've collected with the MyQuake software and MyQuake system. My colleague has went ahead and has taken data and has saved 7 different files for me to analyze. Each file was data taken at one specific frequency, and I'm going to load up this first data file in Excel. And what I want to do first is highlight the 3 columns. I just left-clicked on these columns and dragged, and I want to visualize that data, so I went to Insert, or I can go to Insert, Scatter Plot, and a Smooth Scatter Plot just to make it easy to see. Now that I've plotted it, I'm going to expand it out, and we can see that the data is pretty noisy, and that's exactly what we saw when we ran the LabVIEW software. The first thing that I want to know is which column of data, A or B, represents the accelerometer at the base and the accelerometer at the roof of the model. Well, my colleague already told me that the accelerometer at the base was accelerometer B, which is this red curve here, and the accelerometer at the roof was accelerometer A, or the blue curve here. Normally when you analyze this data, you want to get the earthquake frequency and the peak acceleration at the roof. To get the earthquake frequency, normally you would want to look at the accelerometer signal at the base. So in my case, it's that red curve. And so I'm just going to isolate that curve. I'm going to click on the other one and just delete it. So now I've just got one curve to look at. To get frequency of the earthquake, I need to know the amount of shaking cycles per second of the quake. So I can see that in this periodic function there's like this cycle going up and down, and I'm going to say that these cycles start at 0.96 seconds. So the start time is 0.96 seconds. And let's see, I started here, and if you go over one cycle, and then 2 cycles, and then 3 cycles, 4 cycles, 5 cycles, let's say it ends here. After 5 cycles, I'm hovering over another data point, and it says that the ending time is 6.232 seconds. Let's do that over. Start time was that, and I said 6.232 seconds. So that means the total time between the 5 cycles was the end time minus the start time. I'm using Excel's formulas to help me out. And so the total time was about 5.3 seconds. And I said again that the number of cycles I counted was 5. So how do you get frequency? Well, frequency is the number of cycles per second. So I'm going to use Excel's formula capability again and go equals 5 cycles divided by my total time of 5.272 seconds, and that's a frequency of 0.95 hertz. And let me just put units there for me so I know that. So I've got the approximate shaking frequency for this particular data file. What do I need next? I need the peak acceleration at the roof. Well, if I'm going to get that, then I want to analyze the data from the A accelerometer. If I click on my graph and click on the data points, I can see what the source data is. I can see that this graph right now is plotting the accelerometer B data versus time. If I want to look at accelerometer A data versus time, I can just click on this little box here, left click on that, and I'm dragging it over to this side, and all of a sudden I'm looking at the accelerometer A data. So that's great, and you can see it's a lot cleaner. I'm going to look for the peak in this data, which looks to be about here, and if I hover over that data point and I look at the y coordinate, I see that the peak acceleration is about 0.036 Gs. So 0.036 Gs, that was our peak acceleration. Okay, so the 2 data points, or 2 numbers that I need, are these 2. What I can do is write those numbers down in my notebook and say that for this data file I've got this frequency for the earthquake and this peak acceleration. Because I've already got a computer in front of me though, I'm going to just go ahead and record that in a master spreadsheet. I'll go and create a new Excel worksheet, and I'm going to call it Seismic Spectrum, because that's where all my overall data is going to be saved. And if I open that up, it's blank. So let's copy over these numbers that I just got. I know that in my master seismic spectrum worksheet, I want to make one column with frequency in hertz and another column saying peak acceleration in G's. Let's put the file number just for my reference to file number. So this is file number 1, and we saw that the frequency was this number. So what I can do is right click, copy, and then go over here, right click, paste. I'm going to paste just the values, because if I only just paste normal, it gives me this weird error, and that's because I used a formula. So I'm going to undo that. Instead, I want to right click and just paste the values, and then it pastes fine. And I could do the same thing for peak acceleration, copy and paste, and there you go. I'm going to save that. Let's just bold that so I know it's a heading. And okay, I'm done analyzing that first file. So now that I know how to do that, I'm going to close out this first file, and I could save the data, but if I do, make sure to save it as an Excel file. It'll give you this pop-up. So in any case, I'm actually not interested in saving anything, so I'm going to just cancel all that. I'm just going to not save and close that out. This is the only file I want to save. So next, I looked at Quake Data 1. Now I want to look at Quake Data 2. So just as a quick review, I highlight the data. I'm going to visualize it by plotting it in a scatter plot. And normally I want to look at the acceleration at the base to find my quake frequency. Here my acceleration at the base for me is accelerometer B, and it's red in this graph. When it's really noisy like that, like you can see, when it's really hard to see a starting and ending point for your cycles, you can just go ahead and use the roof accelerometer data to try and get your frequency. Because the roof accelerometer data here, this blue curve, is really much smoother than my base acceleration data. It's not bumping around as much. So, I mean, it's not ideal, but I can still get some data. I'm going to go and delete accelerometer B's data and just look at accelerometer A. Now look how smooth that is. I'm going to get my frequency first. So let's say the start time is 0. And after, so you start here after 1 cycle, and then 2 cycles, and then 3 cycles, and 4 cycles, and 5 cycles, and 6 cycles. After 6 cycles, you're approximately here. I hover over that point, and it tells me 4.605 seconds has passed. So let's see that. 4.605 seconds have passed, and that was my end time. So total time is the same as the end time. That's fine. And I counted 1, 2, 3, 4, 5, 6 cycles, right? So I'll put that down. And so the frequency then was 6 cycles divided by 4.605 seconds. And in other words, the frequency was 1.3 cycles per second, or 1.3 hertz. Excellent. So this is the accelerometer data at the roof, so I already know, I'm already looking at the correct data to get the peak acceleration. And it looks like the peak acceleration is 0.0565 Gs. So 0.0565 Gs was my peak acceleration. Now I'm just putting all these notes in this Excel file purely for these two numbers. So I'm going to go ahead and copy those two numbers to my master Excel file, and I can right click, paste just the values. It's not really in the right format, so let's drag that around to where it should be. Okay, so file number 2 says that the frequency was 1.3 hertz and the peak acceleration was a little higher, 0.05 Gs. Let's save that. And you would continue doing this analysis for the rest of these files. We've gone ahead and analyzed all the files 1 through 7, and we've created our complete table that we need to create a seismic spectrum. We have our frequency, and at each frequency we have our peak acceleration experienced at the roof. That's exactly what we need. So to create our seismic spectrum, I'm going to highlight just our data that we need, and I'm going to insert a scatter plot. Because we have so few data points, I'm going to choose to look at a scatter plot with straight lines and markers, and it creates a nice graph here. Now, this graph is great. It shows how when my frequency increases, the peak acceleration also increases up to a certain point. That's what we need. But it's kind of not ready for professional publication. It's not. I wouldn't give this graph to someone else to interpret yet. It's missing axes. The title doesn't make any sense. So let's clean this up a bit. What I would do first, let's get rid of these lines. I'm clicking on it and just clicking delete. That'll make it easier to see. Because I only have one curve here, there's no reason to have a legend, so I'll delete that too. And this title doesn't make any sense. It's not just peak acceleration. It is a seismic spectrum for my model that I'm testing. I want to give this graph some axes labels. So I'm going to click on the graph and go up to layout and click on axis titles, insert a horizontal axis title, and also insert a vertical axis title. Let's make it a rotated title. So the x-axis is our frequency, our earthquake frequency in hertz, or our shake table frequency. And the y-axis data is what? It's your peak acceleration in Gs. So I'll just label that. And that actually looks pretty good. Just because I'm only interested in the spectrum from 0.5 to 2 hertz, I might want to change the axis to 0.5 to 2 hertz, but I mean, this doesn't really hurt. It's still giving useful data, and so I won't change the axis. If I wanted to, I could just double click on the axis and it brings up all these options, and I could change the minimum to like 0.5 if I wanted to, and then you just close it and see how it changes that. So this actually looks pretty good, and I can copy this over to my document.